those. So we're gonna just
120.
we're just gonna do one of these things. 120 everywhere. Right? Simple. Now we still don't want to do the reciprocal formula. What else can we do? We have two values on each of our resistors, right? How do we solve for our amps on our parallel circuit?
Right.
It's exactly the same. When you
Our
formulas are the same for a series of parallel circuits to find Ohm's law hasn't changed. The rules have changed for the circuit, but Ohm's law hasn't changed. So we still look into that circle. We have E is essentially V. E and V are the same thing. E and V and EMF and electrical potential. It's all the same thing. So we're going to take that wheel on your left-hand side. We're going to cover up the A, because we don't know our amps.
Divide.
We're going to take our voltage divided by our resistance. So we're going to take 120 divided by 60 ohms, right? Which comes up to 2. Oh, wait, I remember how this works. If I have 2 amps going through here, then I'm going to have 2 amps going through the whole circuit, so my total amps is 2 amps, correct? And so you say no?
No, I said, oh. Yeah,
Oh?
You're right.
Yeah, right.
Right. They're additive? Is that what you said?
Yeah.
They're additive. I don't want to assume that my ampacity here is the same everywhere. It's only the ampacity at this load. If this load is 2 amps, that's different than this one and this one on a parallel circuit. Well, let's find out if that's true. We have 120 volts here. We have 80 ohms here.
1.5.
1.5. John says 1.5. What about the next one?
One.
John, you got it? Just one? 120 divided by 120 is 1? Good. I might have been able to do that in my head. So now we can see that each of these resistors have a different amount of ampacity on them. How do we solve for total amps? Someone said it earlier. Add. So we're going to go 2 times 1.5 times 1, which is equal to what, 4.5? 4.5? So now we can solve for our ohms without doing the reciprocal formula. We have 120, and we're going to divide that by our ampacity. So our voltage divided by our ampacity. Our E divided by our A is equal to our R. 120 divided by 4.5 is? Third 20 something?
26.66.
26.66. We have one more value to solve for, and then you've completely finished series and parallel circuits. Hopefully, to some level of comprehension. You okay? It's been a long day, huh? Alright, so what's our wattage?
Volts times amps.
So volts times our ampacity is?
120 times 4.5.
Which is equal to, is that 900 something?
My phone died.
46.
540.
I think you're more
540
closer.
sounds good.
540?
Yeah. So 120 times 4.5, right?
120 times 4.5. Alright. So how comfortable do you feel with the parallel circuits? No, not at all?
You
Get it?
Castle? Got it? How do you feel about parallel circuits?
I'm tired. We still kind of trying to figure out the math. I mean, the math is easy. It's just
The relationships.
just where it placed and what to multiply.
Yeah, we use it.
How's this? Good? Good?
I just hooked up can lights.
I feel good, but I wonder how I'll feel in like 15
There's
minutes.
6 can lights on my
Oh, yeah, I'll see you.
head. They don't work though, but
I don't wanna hurt your brains.
This got me thinking, I gotta go back and make sure I did all my shit
oh
right.
man, your shit's like
I wanna catch fire, don't you?
yeah.
I noticed outside, man, where the water faucet's at, the ground wire, it's not attached.
Oh, on your hose.
Yeah, on the spigot.
It don't matter, man. You
Don't
put some hot wire right
Don't worry,
there.
my pool pump's not grounded.
Thanks for inviting me over.
Yeah.
Come on over.
You got detention. You got detention today.
Damn, dude.
Hard orange. Hard orange. Oh shit, get my rust up. My freezer.
Yeah.
Frozen oil.
Divided 120 by 4.5. These glasses make me more blind and blind every time I put them on. You know? I can see fine. I got to see fine for I see good when I started over there now. I want the glasses now.
Me too.
Shit.
Alright, so let's look at the page with the text again. Very short rules on this one. So this is the rule for series parallel circuits. A circuit that has both resistors in series and in parallel. To determine any unknown values, the circuit is simplified by breaking it into series or parallel circuits or parts. Let's see, I believe we do R1 and R2.
Tricky dicky.
Alright. I guess I'll do. So we know for this circuit, we're going to start off with 120 volts. And the only, well, we know 4 other things.
Volts are all the same.
Volts are all, well,
Well,
we'll talk about that. R1, our ohms are 20, and R2 is 40. Sorry, sometimes I scribble. 3 is 10, thank you. And the last one is 50 here. Alright, so
amps will be all the same.
amps will be all the same, volts is all the same. If I test from here to here, what's my voltage? 120 volts. What if I test from here to here?
120.
Nope. We don't know yet because it's 120 volts from here to here. But remember, one of the rules was for all, in this particular case, I'm losing voltage at all of my resistors. So with what I'm measuring from here to here, I'm just measuring the voltage drop of this resistor. Now from here to here, I'm losing 120 volts. So if this was 60, this would be 60. This was 80, this would be 40. Does that make sense? The same thing for this side. If I test from here to here, I don't know where would I be. That would be a parallel circuit from these two. It's kind of averaged among the two, but it would be something completely different. Hopefully you don't have to think about that in the field much. Alright, so we have our circuit, we understand that this is 120 volts, and we understand that from here to here is going to be something other than 120 volts. We don't know what yet. We have our ohms. What's our first step? Can we put 120 volts here, 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 and here? Because this is a series circuit, our voltage is additive. So we're not going to have 120 volts here, which means we're not going to have 120 volts here. What we could do,
Okay,
no, we'll go back, we'll just start
Our
here.
watts. Our watts. Our watts are additive.
Our watts are additive, yeah. But that's not going to help us yet. What would be our first step? Remember the rule on the previous page? We need to break it down into individual circuits. So it says, simplify the circuit by breaking it into series or parallel circuits. So let's just talk about, let's just ignore 3 and 4. Let's just completely ignore this part and just do this part here. We're just going to do this. This is 120 volts. Now, if we're just doing this, what kind of circuit do we have?
Series.
A series circuit. So what were the rules for series circuits?
Amps current's gonna be the same.
The current's going to be the same, good. What else is going to be true? What else is true with a series circuit? Resistance what? What about the resistance?
Oh, it's additive.
The resistance is additive. So if we break this down into series circuits, we're going to do R2 and R1. Our resistance is additive, so we have 20, we have 40. Our resistance here, I'll do this in blue. Our resistance is additive. We have 60 ohms right here. Our current, we don't know that yet. What's our voltage?
220.
120 volts. So now we can solve for our amps. Our amps would be
60 divided by 120. 60.
Oh, the amp will be volts multiplied by amps.
Volts divided by ohms.
volts divided by ohms. That's correct. So 120 divided by your ohms is going to be 2. So we have 2 amps right here on this wire. You guys know what this part, you guys have this particular type of tool here at this facility. You guys know what this part's for?
For the current.
Yeah, it's for, yeah, I can put my, exactly what it's for. But
Inductive current.
it checks inductive current, just like John is saying. So if I put my amp probe here, I don't know what my ampacity is going to be for the entire circuit. But if I put my amp probe here, what is it going to say? My amp probe is here. I'm checking for amps. It's going to say
2 amps.
2 amps. Perfect. Here it's going to be what? How many amps? It's after the first resistor. How much? 2. It's going to be 2 here, everywhere here. It's going to be 2 amps. This
You
whole thing
added
is
the
2
ohms
amps.
together, R1 and R2.
Yeah, 20 and 40.
Oh.
So that's R1 and R2 combined. So we basically took R1 and R2, we combined it over here. We're going to do the same thing for 3 and 4. So let's do that.
120. So you divide.
Alright, so what's our total ohms for R3 and R4?
60.
So we have 10 plus 5, 50, that's 6.
You get the next
10 plus 50 is 60. What's our voltage?
120.
It's still 120 volts. What is our ampacity? 2. So if I put my amp probe, now let's make it tricky. If I put my amp probe here, how many amps am I going to have?
2. 20.
Alright, so far you guys are wrong. If I put my amp probe here, I have
2 amps.
If I put my amp probe here, I have
2 amps.
If I put my amp probe here, I have
2 amps.
But if I put my amp probe here, I have 4.
2, 4.
2 and 2 equal 4. The 2 amps passing through here do not pass through here. So I have 2 amps for this, I have 2 amps for this, so here I would have 4. Does that make sense?
Yeah.
So here I would have,
That's a lot.
here I would have,
4.
yeah. So my total ampacity for the circuit is
2.
4. Yeah, only because the amps are still going through and then these are going to be added.
Now I could do some math, I could go, there's 60 and 60. So I could take 60 divided by 2 and come up with our total ohms. Or I could take 120 divided it by 4 and then give it our total ohms. We're going to get the same number. What's that number?
20 divided by 4.
30.
Equals 30 ohms.
You guys see how we did that?
I do.
Do that again, I'm sorry, I was writing.
So there's two ways we could solve for ohms here. We had 60 ohms here. For this whole circuit, we had 60 ohms. We had 60 ohms here. We have 2 paths for the current to flow. So we're going to take 60 divided by 2. This is the kind of the rule that sometimes is nice, but generally I don't like to use this. What we could do is just take 120 divided by 4. We're going to come up with the same number. So 60 divided by 2 is 30. 120 divided by 4 is 30. Probably a bit easier just to think about this path, this way of doing it. Alright, so what's our total watts?
483.
480,
Amps
so
times
4
volts.
times 120 is 480 watts.
12 kV.
So I said earlier, what would be the voltage drop? What's our voltage drop here? We still don't know the answer to that. Let's solve for that real quick. We'll just do R1 for an example.
Hey,
So we're-
excuse me, for $5 I have the answers to the test.
I need 10 and we're really got it.
R1.
That's not proper.
R1. How many, what do we know about R1? What do we know about R1 now that we can fill in these voids?
You know that is.
It's 2 amps. How do we know that? Because we have 2 amps going through this whole thing, right? And if it goes through here, goes through here, goes through R1. Very good. So we have 2 amps. What's our voltage? Our voltage drop at that resistor
Amps
is
times ohms.
amps times ohms. So 2 times 20 is 40 volts, which means that in R2, I don't even need to really do much math. 120 subtracted from, or 120 minus 40 is going to be 80. So 40 and 80 is 120. I have, if I put my tester here, I'm going to see 40 volts. Alright, so you guys think you got this?
Yeah,
You have any questions about it?
Can we use this sheet to test?
Yeah.
Oh, you're gonna need.
I get you the hell.
Alright, so let's apply this.
Let's take a break.
You guys need a break?
Oh, yes.
Hell yes.
Hell yeah.
Oh,
Alright, well let's take a break. We'll take a 10-minute break. We'll be back in 10 minutes. If not, I'll come looking for you and then I'll just start the
Sounds good,
timer.
boss. Thank you. Let's go check out the break room.